Okay, part 3 of 3, guys. So here's the last one for this week. I want you to understand that this one, you should know how to do every single step of this, but that is if you remember our trigonometry chapter. So what I'm going to do is just walk you through step by step. We want to find, oh, I just realized we're missing a height. So let's make one up. Find the surface area and volume of a right regular pentagonal prism that has a base perimeter of 35 and a height of, I don't know, let's make it, I don't know, something different, 17, and let's do centimeters. Okay, this way we have a label. All right, so here, I got a couple things on here, but this is the prism itself. If you notice, the right part of the title tells us that it's standing straight up. So if I wanted to, I could put, I could put little right angle markers here and show that it's standing straight up. Regular pentagonal prism. So this is important, right? Prism, obviously we have two congruent parallel bases, right? The two pentagons. Pentagonal, we just described that the base has 5 sides each. Bases each have 5 sides. Regular is important. Again, we saw this in our last video. Regular means equilateral and equiangular, which means the base is perfect. It's a perfect pentagon. So what I've done is I've just printed a picture just so we can concentrate on the pentagon alone. So here we go. If the base perimeter, which has 5 sides on it, is 35, well then what do? Well, we're going to divide 35 by 5, and we're going to get 7 centimeters on each side. Okay? Now I'm going to wait to label the last one for obvious reasons. Okay? It is 7, but we're going to bisect that. All right? Well, actually, we're mentioning it. Why don't I write it down right now? So this is 7, just like the other sides, but we are bisecting it into 3.5 each. Okay? Half of 7. Now, you got to be very, very, very careful here, okay? Most students make the mistake and assume that this is an equilateral triangle. It is not. The only time that happens is in a hexagon. Now, for example here, if I were to draw all 5 central angles here, 1, 2, 3, 4, 5, then they would all add up to what, guys? Wouldn't they add up to 1, 2, 3, 4? All 5 angles add up to 360. So in order to find this angle here, I'm going to take 360. Oh, and you know what, guys? Before I forget anything else, all right, make sure your calculators are set to degrees. All right, we're going to use SOHCAHTOA in a minute. But I'm going to take 360 and divide that by 5, which gives me 72 degrees right here. Okay? Now I want you to remember something. If this whole angle is 72 and we bisect it, then that's going to make each of these 36. Okay? All right, so now I want you to remember something also that's really important here. No matter which of these I drew, each of these lengths are the same, which makes this what type of triangle? Not equilateral, right? But that makes this isosceles, which makes these two angles equal. Okay, I'm going to mark those equal. So let's think. If this whole angle is 72 degrees, then I'm going to take 180 minus 72, and I'm going to split them equally. So 180 minus 72 is 108 divided by 2 is 54. So I can't really squeeze that in there, so I'm just going to write 54 degrees and just point a little arrow in there. Okay? Same thing over here. Now you could also use that 180 times n minus 2 formula from earlier in the year, but I just figure, we'll just use isosceles triangles. All right, so here we go. We got a lot that figured out already. This is going to help us try to find the area of this pentagon. So what I want to do here is I'm actually going to write down capital B equals. Capital B is the area of the base, guys. The area of the base is this whole pentagon. So isn't it going to be 5 times the area of this triangle? Okay, so I'm going to write 5 times 1/2 little bh. We'll come back to that in a minute. But we have to find an important bit of information here. Okay, I'm going to call this A. The height of this triangle, it gets this fancy name. It's called the apothem. We mentioned it once or twice earlier in the year. You don't need that name at all, but it's basically the height of this triangle. I am going to use trig. I'm going to pretend that, remember we were drawing little stick figures? My little dude is here. The apothem, or that height, is opposite of the person. And where's 3.5? That's adjacent to the person. So SOHCAHTOA, I'm going to use tangent. So I'm going to say the tangent of the angle, which is 54 degrees, equals opposite over adjacent. So the opposite was A, the adjacent was 3.5, okay? Now what we could do here is, if you remember, we'll put that over 1 and cross multiply. 1 times A is A. 3.5 times the tangent of 54 is exactly that, okay? Now, you guys notice our answers here have the approximate symbols because we are definitely going to get lots of decimals here, all right? So in your answers, just be close, all right? Round properly. All right, so here's what I'm going to do. I'm going to cover this up for a second so you can see my calculator. I don't want it to be blurry. All right, here we go. So I'm going to do 3.5 times the tangent of 54, close it up, and I get about 4.82. Okay, now I want you to take a look at where are we right now. Okay, we want to find the area of this triangle. So the full base of the triangle is 7. What's the height of the triangle? Well, we just figured that out. That's 4.82. So here we go. I think we're about ready to find the area of the base. Notice I'm leaving that decimal on the screen. So the full area of the pentagon, full area of the base, is going to be 5 of those triangles. Well, let's go back to that triangle. What was the full length of the base? Right? It's not 3.5, it's the whole thing. So it's 7. Times the height of the triangle. Well, that's about 4.82. Okay, so now from here, all I'm going to do is type this out. Now notice I'm leaving my decimal, so it's 4.82 or about that. I'm going to do times 7 times a half. Okay, now I want you to notice something. That is not my full area. Okay, I just want to put this on here so you know that this is the triangle. Okay, so the area of one triangle, actually here, I'm going to make this yellow, the whole thing, and then I'm going to put this in yellow. Okay, so that is the area of one triangle. But now I'm going to multiply by 5 to get the full area of all of the pentagon. So my total one base area is going to be about 84.30. And I'm going to use that rounded number for here on out. Okay, but that's the majority of the work. So from here on out, ladies and gentlemen, we're going to use our formulas and wrap this thing up. So I'm going to say surface area equals pH plus 2 capital B's. But now, guys, look, we just found the capital B. So again, I'm leaving that decimal on my screen. Now let's go ahead, all right? Formula, substitute, and then finally our answer with a label, okay? So what I'm going to do here is I'm going to take the perimeter of the base, which they told us was 35, the height of the prism, which we made up before was 17, okay? And then 2 base areas. So that's going to be about 84.3. All right, so I'm going to clear this all out, and I'm just going to type that whole thing in there. Here we go. 35 times 17 plus 2 times 84.30. Enter. I'm getting somewhere around 763.6. I'm going to just put that right down in my final answer. Okay, it's approximated. All you got to do is be close. And I'm going to label that with centimeters squared. Okay. All right. Now we're just about finished. Okay. I do want to label the net before we go, though. But volume is going to be area of the base times the height. Area of the base, it's about 84.3 or 84.30, same thing. And then the height of the prism. We're going to take the area of the bottom, the base, and multiply it by how tall it is, which we said was about 7, which is 17. Okay. 17 times 84.30. Enter. I'm getting about 1,433.10, which I'll write down here, but with a label of centimeters, what? Cubed. Okay? All right, before you guys go, I do think it's important to take what we've just done and label the measurements on the net. So what was this length here? Well, that's the height of your prism. So that was 17, and it's 17 all the way through. Okay. All right, what was the length of each side of the pentagon? Well, each of them were 7s. Okay, 7 here as well. Okay, but think about it. This base had this wrapped around it. So that means all of these are 7s. All right, and just to show you what some of our answers means, I'm going to take 7 times 17, and that's going to give me 119. So each of these have an area of 119, okay? So that would have told me that 595 was my lateral area. Okay, that would have been shown right here. If I would have just taken the extra time, maybe I'll write it right now. Okay? All right, and then finally, I just wanted to make sure that you guys understood that this length right here was our apothem, all right? Or basically just the height of that triangle, which we found to be about 4.82. All right, so I think that wraps us all up, guys. We got our surface area and volume, and we practiced how to find, oh, you gotta be, there we go. Okay, how to find the area of a regular pentagon.